For millennia, humanity has gazed in awe at megalithic structures like the pyramids of Giza, Stonehenge, and the colossal Olmec heads. How did ancient civilizations, without modern machinery, move stones weighing tons, sometimes hundreds of tons? Were they aided by forgotten technologies, divine intervention, or simply ingenious engineering? Join us as we delve into the mysteries of ancient stone moving, separating fact from fiction and revealing the remarkable ingenuity of our ancestors. Across the globe, imposing structures built from massive stones challenge our understanding of ancient capabilities. From the monolithic statues of Easter Island to the cyclopean walls of Sacsayhuaman in Peru, the scale is staggering. These weren't just small rocks. We're talking stones that rival modern building materials in size and weight. The immediate question is, how on earth did they do it? This question has fueled speculation and debate for centuries, blurring the lines between historical fact and speculative fiction. The Great Pyramid of Giza stands as a testament to ancient Egyptian engineering. Constructed from over 2.3 million stone blocks, some weighing up to 80 tons, its precision and sheer size are mind-boggling. The conventional theory involves ramps, levers, and immense manpower. But logistical challenges abound. How do they transport these colossal blocks across the desert? How do they lift them hundreds of feet into the air with such accuracy? Skepticism about simple ramps persists, urging us to consider alternative possibilities. Despite the mysteries surrounding large constructions, the basic principles of levers and inclined planes likely played a crucial role. Levers could multiply the force applied, allowing smaller teams to maneuver heavy objects. Inclined planes reduced the force needed to lift objects vertically by distributing it over a longer distance. Experimentation and observation were key. The ancient Egyptians likely refined these techniques over generations, optimizing their use for quarrying, transporting, and positioning stones. Ramps of various designs were likely used extensively. Straight ramps required enormous amounts of material and became increasingly impractical as structures grew taller. Spiral ramps, winding around the structure, offered a more space-efficient solution. However, even spiral ramps presented challenges in maneuvering large stones around tight corners. The type of ramp and the resources required depend on the specific construction project and terrain. Recent experiments suggest that the ancient Egyptians may have employed a clever technique involving wet sand. By wetting the sand in front of a sledge carrying a heavy stone, they could reduce friction and make the stone easier to pull. The right amount of moisture created capillary bridges, binding the sand grains together, and thus having the force needed to drag the sledge. This simple yet ingenious method could significantly increase the efficiency of stone transport. While technology played a role, the movement of massive stones ultimately required immense manpower. Historians estimate that thousands of workers were involved in building projects like the Great Pyramid. Organizing and coordinating such a workforce demanded sophisticated social organization and logistics. Workers were likely organized into teams, each responsible for a specific task. The centralized control of resources and labor was essential for successful megalithic construction. Stonehenge, in England, presents a different set of challenges. The blue stones, some weighing several tons, were transported over 150 miles from Wales. The exact methods used remain a topic of debate. Were they rolled on logs? Carried on sledges? Flotation down rivers is another possibility. The sheer distance and the varied terrain make this one of the most perplexing examples of ancient stone transport. The monolithic statues of Easter Island, known as Moai, are perhaps the most enigmatic of all megalithic structures. Tradition says they were walked into position. Recent experiments, using ropes and a coordinated rocking motion, have demonstrated that it is indeed possible to move the Moai upright over short distances. This challenges the more conventional theory of dragging them on sledges and suggests a more nuanced understanding of Rapa Nui ingenuity. In Mesoamerica, the Olmec civilization created colossal heads carved from basalt boulders, some weighing over 20 tons. These heads were transported from quarries up to 80 kilometers away. Given the absence of pack animals or wheeled vehicles, the Olmecs likely relied on rafts to move the stones along rivers and sledges to haul them across land. Their ability to organize and execute such complex logistical operations speaks to their advanced societal structure. The process began with quarrying. Ancient civilizations use a variety of methods to extract stone from the earth. Egyptian quarries employed dolerite hammers to pound out softer stones. The Romans used fire setting, heating the rock face and then rapidly cooling it with water, causing it to fracture. The choice of quarrying technique depended on the type of stone and the available tools. Achieving the precision seen in megalithic structures required sophisticated methods of measurement. Ancient Egyptians used knotted ropes to measure distances and plumb bobs to ensure vertical alignment. They also possessed a keen understanding of geometry, which was essential for laying out accurate foundations and aligning structures to celestial events. Their tools may have been simple, but their knowledge was profound. The construction of megalithic structures was often intertwined with religious beliefs and rituals. These monuments were not simply feats of engineering. They were expressions of faith and power. The process of quarrying, transporting, and erecting stones may have been accompanied by elaborate ceremonies, reinforcing the importance of the project and uniting the community behind a common goal. While we have a better understanding of the techniques used to move massive stones, some mysteries persist. The exact sequence of events, the specific tools employed, and the full extent of ancient knowledge remain subjects of ongoing research. It is crucial to avoid simplistic explanations and acknowledge the complexity of these ancient feats. Studying ancient stone moving provides valuable insights into the ingenuity, resourcefulness, and social organization of past civilizations. Their accomplishments demonstrate that even without modern technology, humans can achieve remarkable feats through a combination of ingenuity, collaboration, and perseverance. Their legacy continues to inspire and challenge us today. The movement of massive stones in ancient times was not magic, but a testament to human ingenuity and collaboration. By combining simple machines, meticulous planning, and coordinated labor, ancient civilizations were able to create enduring monuments that continue to inspire awe and wonder. While some mysteries may remain, the evidence points to a remarkable understanding of physics, engineering, and the power of collective effort.